Chairman for the afternoon session with lots of people.
The first speaker is Kyoji Saito from WILS, and he's going to talk us about semi-interdimensional structures.
Thank you very much for the introduction, and also giving me this talk. The title is Semi-infinite structure associated with hyperbolic fluid system. I will explain the motivation soon. Before starting, most of you don't know, not use semi-infinite structure, what it is. And actually, in my knowledge, besides me, only conservative and parameter is, there could be somewhere else. In my knowledge, that is the only case. So actually, explain what I want to mean by this notion. For standard Hodge structure, for instance, if you look at the compact scalar variety, on the cohomology group, you have some decreasing filtration called Hodge filtration. And that is very well classical and well studied. In fact, even nowadays, very deep, interesting logic. And what I'm going to talk is not that one, but some variation of Hodge structure. That means some family of Hodge structure. That means there is some parameter space, yes, and you are not going to consider parameter space for either study case. It is called scalar. On the space, you are not looking at one vector space, vector bundle. Then this vector bundle has filtrations. This is the OS vector bundle with OS singularity. That's OS model, pre-models. Now, in this case, tangent bundle also rank equal to the dimension base. And then it has a decreasing sequence of all three modules, submodules. In the Hodge theory, usually put 1, 2, 3, but historical reason I put minus time. So there is some decreasing sequence of all three submodules. And then there is some covariant derivation action. That means you consider the chief of harmonic vector field and that acts on each filter, say minus k, its transversality course, it goes to one aspect. This is the type of filtration. And furthermore, there should exist some positive filtration and together with the opposite filtration and Hodge filtration intersection defines some graded piece and some further structure, which I shall describe more precisely, so I skip details here. But one another important point is there exists so-called primitive element or primitive form, some particular element such that this derivation or covariant differentiation on this just induces isomorphism. That means there exists some element which generate all homology plus H module by derivation of this. And this is that is the reason called primitive. Somehow this is a primitive Carabiao family varieties. Actually, some other example of this I used long time ago, 45, nearly half century before, as a stereo primitive form. At that time, I was not conscious this was Hodge filtration. Some years later, 85 or 6, when I was discussing Delhi, he said, oh, you are looking Hodge filtration. Since it was infinite module, I didn't thought this is Hodge theory, but he said, oh, this is Hodge theory. And that since then I switched to just Hodge filtration. Then some 10 years ago, Baranikov and Kontsevich introduced similar family associated to the family of Carabiao variety. And then they constructed again such object where this primitive element led by the choice of some section of canonical bound. So in this way, this structure somehow, this is what I wanted to say on this structure. But the interest of this talk is not repeating the classical theory here. Hyperbolic fluid system of rank 2. Yeah. I shall later explain what is a hyperbolic fluid system. I'll go into somehow this root system you can associate to some family of variety as if you point an isolated singular point, then in the Milnor fiber, for instance, there is some particular homology classes called vanishing cycle, just some degenerate to some more singularities. And this set of vanishing cycles form some axiomatic structure called root system. For instance, this morning, Iyama-san was talking about this finite root system case. That root system are associated with simple singularities. In case there are many other root systems in general. Hybrid root system can never appear the vanishing cycle or root system. there are many reasons. One typical reason is we should describe data on monodromy and eigenvalue of monodromy, which has its origin in geometry. It is the Kelsen unipotent, the eigenvalue, the root of unity. I'm going to discuss the whose one Fox real eigenvalue. So the nature is completely nearly 90-degree rotated to the classical geometric station. So it is actually there are several other reasons. The system, not geometry. Nevertheless, recently, last year, I found even for such good system, you can construct such family of which structure also primitive form. That is one reason. So the first motivation is one reason. Motivation part is non-geometric primitive. Then where such primitive form appears? I said, in the classical primitive form theory, it appears some particular differential form to define the global period map. And in the considered variable, it comes also from the settlement comment one. Another such structure, from where it appears. And still, I don't have good explanation question for how it appears. Second interest is the following. If you describe such object, integrating such so-called primitive form, you can define a global period map from S to be exact, some complement of discrete covering space. Some integrating these primitive forms, you get some period domain.
I think, what is this key? The degree of this primitive form.
Okay. From 1, 2, 3, 4, 5.
Do you require it for every key,
Yeah.
particular key?
To be exact, if I know one, the others are just their shift operator created other. So I essentially there is one. I'm sorry, I'm explaining a little. Yeah, and K equal 1 or 2 case is the most historically US studied and interesting case. But recent study of Bridgeland, the stability conditions, I will necessarily to consider all cases. Okay, so you define period map. The second interest is in this case, associated to such setting, just some Arabia, so to say. The Ginsburg construction of some Carabiao theory. And so she was, I don't know, depending on K also. Then this, notation, I'm sorry, I have it here. Then you can consider the so-called stability conditions for this category. And if you know the some construction, Bridgeland construction, it uses central charge in the physics. So then central charge is exactly mirror symmetric to the integral of primitive form. That means this space natural covering to this space. And actually this for construction is confirmed some particular case in the classical case. For instance, A by Bridgeland and Smith or somebody else. And also other case by Ikeda and so. Then it is again the second question. Comparison. of this various domain. And the stability condition set. This we are completing. And unfortunately, second part is almost nothing done. As I just mentioned as a motivation, I wanted to yesterday to calculate some part of this, but unfortunately, my phone switched to today and this calculation.
If it were tomorrow, you would finish it.
No, I'm writing down the last of this, the differential equation in this. And then if I know that I can describe this, then begin to think. But this is later, the next problem cannot do. I shall work with some people working on this. You can actually get up. So, yeah.
May I ask you this, do any hour is it called?
No.
Not called.
For instance, in the relative form case, for instance, typical case is N2 case, elliptic integral case, but even in that case, you consider a punctured elliptic curve. And one punctured elliptic curve theory corresponds to A2 type primitive form, two punctured elliptic curve theory corresponds to B2 type, and three punctured elliptic curve theory corresponds to B2 type. So always somehow open. But anyhow, so this is a background and let me start more concretely. So because of this new feature that it is non-classical, at the beginning I was trying to study all cases. When I give title of my talk to Alexei, I was saying hyperbolic system. After calculating general hyperbolic system from the present station, so I restrict myself only for case rank 2. The rank 2 case, in some sense, everything is hand calculation. Instead of using some general framework, you can calculate everything. So I begin to talk with rank 2 case. Then you start with quantum matrix. Quantum matrix is somehow intersection form for some good system where PQ are still integers. If you know that some D theory for PQ, P times Q equal 1, this quantum matrix, is correspond to actual system, and PQ equals 2, P times Q equals 2, is a 1 times 2 or 2 times 1. This corresponds to the root system of type D2 of C2. And this is 3. This quantum matrix corresponds to G2 prime root system. And this is 4. It is degenerate, and this is a kind of system of A1 cube. So these cases are rather well studied. And if you like, you contrast this principal form theory in a classical style and theory. So far in my understanding, no problem. But then the question, when PQ equals bigger than 4, then this matrix has signature 1, minus 1. Minus negative eigenvalue. That is the so-called hypothesis. So for this starting data, I'm going to construct this structure and also construct such object and construct this period. That is the plan of this talk. And
Sorry, your Atama matrix is not symmetric, so what is the signature?
yes. If you know the technique in the classical continuity theory, you multiply diagonal matrix either from left or right, depending on the viewpoint. Then it becomes symmetric. In this case,
Symmetrizing.
yeah. In this case, PQ, I forgot what is the symmetrization. Point among symmetrization, this one. And this has, under this condition, this is signature. Okay, this binomial form, let us call I defined on the vector space found by this basis, one-dimensional space for alpha and beta basis. So on this F, you get this symmetric binomial form. And then you define here, from here, everything elementary. Let me describe. The reflection action, depending on alpha, is to define standard corrected form. You define reflection action is the kind of some group here. This is the hyperbolic group. There are some vectors which obviously are on F, and but on F, not the classical right class base. You don't study the everything. So you consider the right form of it. That means like F, you have here is here letter. You consider it vector space. Then you consider the quadratic form. That's it. And then you consider the right form. Let us call this area. And this is some form like this. But it has two components. So you decompose into the component and they call it one of them B class. And this is so-called the right form. And then what is the other root? How do you just orbital union orbital? This is a so-called system. Then for any gamma, you define also the reflection, and the reflection fixed on hyperplane field, which for H gamma, and it reflects. That means this light form is invariant by the group action. I forgot to say. W is nothing but equal to the group generated by all reflection. So here are the group on this light form properly discontinuous in this other area. I don't care. So then complexifying this equation, you consider the following. In the complexification, you look at the scope of the tube domain that is studied in the classical automatic form theory.
And the roots are outside of this light.
That's somewhere going to better, gamma, better, something. If roots are on this atomic plane. So you look at domain. Then on this so-called tube domain, your group acts properly discontinuous. So you can consider the modular function and the invariant theory on this domain. But to be exact, I prefer this complete system code. This work in this way.
Sorry.
This is hard.
Two.
Then
Just this. Wasn't
this one
it? Is it that square?
yeah, you are like this letter. Then since reflection time, I skip many details, but you are going to consider the ring of harmonic function. In this case, you cannot consider the polynomial invariant theory, but you should consider the polynomial invariant theory. But in this case, again, by handler, it's essentially so that there are essentially two algebraically independent invariant ring which generates all invariants. What I meant by this strange notation is the following. Here, left-hand side, I'm looking at harmonic function ring, here polynomial ring. There is some gap we need to somehow complete by analytical. That process, I can explain details, but in this talk, I prefer not to go too much such details, so I just say. So what are S1 and S2? Roughly speaking, this Q domain. If you remember this right form, I forgot to say there is some Coxeter element in this variable. That is the product of the generator of the reflection. And this Coxeter element, if you look at the eigenvalues of this Coxeter element, as I said, in the classical geometric setting of primitive form theory, this root of unit, eigenvalue, the root of unit. In this case, there are two positive real roots which are inverse to each other, and two eigenvectors, real eigenvector on the edge of this right cone, called xi plus and xi minus. So already setting is completely different from classical invariant itself. Nevertheless, I'm going to continue this story. In this case, I switched the coordinates. I was using the base compound, the base. Now I choose this without fraction Lyman basis. And so my element of here, I shall use without plus such expression, U1. Then the proportion of U plus minus U minus not maybe there is some doubly equivariant vibrations. And there is some doubly variable invariant zero section, so that this space has natural product expression. And this projection to this product relation. So projection to this C star direction is the coordinate because it's true. So S2 is already such easily obtained visualization. But another invariant comes from the inverse portion of this space by the variable, and it's too much technical detail. So I just give very pictorially explained what is. So variable in this case, is shifting is harmful. The composition of this coordinate, this encryption hyperplane goes through this. And its wide group action is just acting as a rotation. So it's too much complicated so that you take the logarithms of this q plus u minus. Then it goes to some tube domain where reflection hyperplane are now points. Real. And still, I don't want to go too much detail, but here in this space, one should standard reflections, so for instance, W gamma acts on this coordinate, let us call this coordinate Z, then W gamma Z to some constant. Yeah, or you can skip all detail for the explanation for the structure. This is too much detail, but I just there is some number for gamma. There is some. This is gamma. So in this way, your variable function on this space by reflection. Then finally, your S2 is obtained. Here, no geometric property comes again very clearly. So I want to just like this. You consider y equal exponential of HR minus minus z minus alpha. And then this one is equal to y plus y minus. Yeah, I'm sorry to a little bit too technical, but here HR was equal to Fokker number is 2 pi root minus 1 divided by tau alpha. It's also too much technical, but I just showed this in order to show how this theory is different than classical theory. In the classical theory, Fokker number is defined as the order of Fokker element, and obviously that is real number, real infinite. But here I introduced here, since in that case, the eigenvalue of the Fokker transformation is root of unity, and using this root of unity, you can recover the Fokker number in this formula. And if you apply the same formula for this case, you get the imaginary number of Fokker number. So you need to use imaginary Fokker number to get the invariant theory. So anyhow, it's a technical story, so I don't want to go into it. So anyhow, in this way, you get the description of the invariant tree. You wanted
I mean, my question was this Waldorf, is it just the infinite dihedral?
Sorry?
Infinite dihedral.
Kind of infinite dihedral group, but here is some, there is one, not all. But the
Instances for functional group.
Yeah, that's true. But the group is 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 it's it's infinite cyclic extension of this the exactly what you said.
And this picture didn't use your carton picture, so they just let it high. You didn't use your original carton matrix. This picture only this letter.
Symmetry is absolute. But, this is a little bit ambiguous here. The symmetrization of the intrinsic data, mostly intrinsic it is. But it's a small technical things. So far I got some description and maybe I do want to go to the construction of project integration. So before again, so our space omega quotient by the value of maybe it's a group of vector using roughly speaking, using S1, S2, it is state of C. Yeah. Okay, then on this quotient space, that is for some reason it was called still the R in the beginning of this code. Here is still the R. So on this space, I'm going to construct the semi-fit Hodge structure with some primitive form. So how to do that? The vector bundle is easy, that is nothing but this set. But it's any detail, or I'm sorry, I use S because my name is S, but historically, H2 family is often described as S for some other reason. So let's use S. Then I'm going to consider the following thing. Yes, not like there's the simple for vector field in this space. That is obviously free module of lambda. Yeah. And obviously the original I intersection form psi was originally the intersection form not only on F, on the tangent bundle of F. Then it induces also within that it's not by portion of we get up to say projection to the portion space. How there is some induced linear form on this space. But this is not regular, but it has poles. Discriminant. And what is this discriminant? I want to explain what is the discriminant. The differential hyperplexy here on this space goes down to these points and so on. So finally, it goes down to this space. You get some image of the union of reflection hyperplane above. Some divisor here is the let us write down the equation here. Is very technical detail. This detail is necessary to determine obstruction. In my memory, the equation, because of some other reason, we put square, since the half is a semi-invariant, which is quite important in the invariant theory. I don't come to this story now. And you consider this bilinear form on this tangent bundle also induces the dual form in the differential form. So I put dsI dsj here. And the discriminant defined in this form is equal to some constant which depending on the x constant number where the square one here one. So the discriminant look like in this coordinate system some parallel two lines. In real geometry, it is not parallel line, but it is exponentially scale by using the sum. Anyhow, it's for independent device. Okay, then now we are going to come back to the description of this the module structure, the infinite structure. In relativity theory, but just let me explain the before. Should introduce some notion. We are looking at the space of differential vector field. Then it's dual space is space of one form with this S space. Then inside this, you consider so-called logarithmic vector field along with the discriminant that is defined by the vector field harmonic vector field whose operation on the equation of discriminant goes to the ideal row, defining ideal row vector field. This is you define also logarithmic transforms. The space omega, which may have just simple form along the discriminant and whose differential is still simple form. And it's not hard to show that they are dual. That means more they are dual modules in each and I think it's generalized notion of Berlin. When Berlin was studying Hodge structure, he was introducing logarithm form, but this is a generalized style, essentially similar object. Then one key point also is again a little bit. I cannot use it in the data, nevertheless, I am better to means of the following diagram first. You have one home space. On this space, you remember that the ideal form is defining bilinear form on this. That means if you take some element omega, I of omega, and here is the free space, it defines the dual object in the dual object. That means this I star defines the map to derivation. But actually, it goes to isomorphic to the logarithmic vector field. On the other hand, all Roman vector field again is defined by inner product. I map to one form space, then it goes to large one form space. And this becomes isomorphic. And this diagram form. And this shall be very often used. I don't want to explain details. Is used. So, okay, using these data now, I'm coming to the construction project. It's not an initial statement that there exists a unique number which map the close the to some which may have fallen along the discriminant and notation or pair of delta 1 delta 2 denoted by number of delta 1 delta 2 such that yes, three properties. One number with a connection. That means it is collinear with respect to delta 1 and Leibniz linear in delta 2. Okay. More linear delta 1. Leibniz in there is such. The economic is regard when for without class what means if you make a derivation of the I from delta 2 delta 3 equal I now we are delta 1 delta 2 delta 3 it is more or less delta 2 delta 1 delta 3 calculation is singular discussion free. That means number of delta 1, delta 2 equal number delta 2, delta 1 is equal to the bracket. And you can see that there exists a unique delta satisfying these rules. So in this way, your derivation on this module. So I'm now going to the test as a solution. candidate of the Hodge module H. So far, everything is standard, more or less, nothing very difficult. And also, if you know that some general theory framework, you can do it. But here, there is some new phenomena happening. And that is still ununderstandable for me why it is. The result is true, but proportion.
Excuse me, ask. Sorry, you have a connection on the tangent band.
Yes.
Is it some kind of Riemannian connection? Where do you get it? It's not easy.
These three conditions.
So it's a Riemannian connection, kind of a Riemann connection.
Yes, yes. Oh,
Corresponding to Riemann.
if you know the classical crystal symbol,
Yes.
you write down. You can write them by the crystal symbol. That type of connection. But it has its origin.
Yes, yes. Corresponding to Riemannian match. Something like this. Except the metric seems to be constant. I'm a little confused.
Or it will become.
Yes, yes, yes. It should be something.
Say more carefully, it has logarithmic connection in the sense of
Yes, yes.
logarithmic. That means connection regular singular. Long distance. That's there.
It's flat. Ah, okay.
Yeah, of course, the Riemann metric is a Riemann connection in general, not
Okay.
but this one.
It's kind of Frobenius manifold type thing.
Yeah, this structure induces the Frobenius structure later. But then exists global vector field in this space. Satisfying the following three conditions. You consider the following three conditions, not proportion definition. I'm sorry, when I was introducing the logarithmic vector field here, yeah. I'm saying that this stuff make the isomorphism of then here you are going to consider the particular differential form Q. You remember Q is a quadratic form, so it is a quadratic function, and it's easy to see it is invariant by production. So Q is some element in the invariant ring. Then you consider differential of Q divided by the constant number. Again, this is very strange quotient. Since constant number is now pure complex number. It again quite different from classical setting. You consider some object here in this by this isomorphism, it goes to some particular vector field, which one is we call Euler vector. Lack of time, I don't want to go too much detail, but using this Euler vector field, this is one degree 0. The F2 is degree H2, in this way, the invariant ring is not naturally integrally graded. So you cannot put the graded structure in the ring. That is another reason we cannot define in the classical style the primitive form. In the classical style primitive form was given by the lowest degree vector field. But in this case, you cannot say lowest degree, since the degrees of the coordinates either 0 or imaginary number. So nevertheless, I'm going to define what is primitive vector. So this is a primitive vector field or primitive derivation. It's the following part.
Did you say what is your H0?
H0. Yeah, later on, you derivate this module as a H0. First, degree will be finite one function. Second function is the free derivative with respect to this D of this. Maybe it's not very complicated because we don't want to go to detail. The third condition, that is the most, here is only pure technical condition. But third condition, this is the most important. The means in the following sense, very false. With respect to the metric of star, by which I mean the secondary derivative of star equals zero. This condition may look a little bit strange, so I will explain this is equivalent condition the following. D somehow in the parameter space S2. D is a vector field which goes to a particular direction. And somehow in the practical theory of primitive function, this is the direction where the function takes energy. That means primitive vector field nothing but the derivation in the direction of energy level. And then how to say? So if you make quotient space, consider the quotient space by the orbits of the D, this is called TR, TR, and you consider the OTR is nothing but the kernel of D or S. Then you are going to consider some particular submodule derivation. That is derivation which commute with D. And this subspace is nothing but just if you take this is the OT module, and if we extend it to the whole module, it recovers the whole vector field. In this sense, this G is some descending of this S into the T direction. But then this condition is equivalent to the D derivative of principle, defining a bilinear form G to 4P. You get degenerate geometric I induced with some particular another metric from this G. And later on I shall call J. And so existence of this metric is equivalent to this second derivative of this zero. Let us call back on it. Then theorem or some result is also this unique solution. This is a data point, the candidate of here primitive form in this plane, this law. Since the lack of time, I don't think I can talk too much more about this, but this is just giving some solving some hypergeometric equation and taking a very strict description of solution of hypergeometric equation. You choose a particular solution of the equation. That proof is very technical, but conceptually you don't also take it. Then you assume this. So under this assumption, then you going start using this the theorem, technical but complicated theorem is the force. This lot of time is spent with many things. Many more things. But and it is finding this primitive element theorem gives me very complicated long logarithm vector field module bijective to the whole vector field. When you don't find what is the interest, this is a theory that means this inverse operator is very defined. In the theory of D module theory, this is so-called pseudo-definite operator. Pseudo-definite operator is defined on this module, on back to this logarithm module. And logarithm, remember that obviously this is a module that we pseudo-differential operator defines this module to this. And then we call this module H0 and H minus K is defined by the iterated action minus K. In this way, you get some sequence of some module and which satisfy some required condition. I haven't explained details, but all three modules with some good condition with respect to the opposite penetration and so on. That I skip. But in order to give me 2 minutes, why then this? Okay. 2 minutes, just to explain the motivation in the motivation I was talking about the period map. So I just mention about the relation of the period.
So H minus one, it's got
The logarithm vector logarithm. Yeah. Yes. So in this way, you get the sequence of three sub-modules which increase to zero. And the intersection is zero is equivalent equation with regulation in our Lagrange theorem. But I just want to state relation with the period map. Otherwise, the motivation is not the same. So remember that primitive form, for instance, the vector, this module vector field, which this minus k. What was that? I forgot to define this is a lambda d inverse minus k t. And then the covariant derivation of this so vector field lambda delta also okay. Okay. In this way, you remember that primitive form plays the role that which filter k plus minus k plus 1 Hodge filter is just obtained by the covariant differentiation of some particular element, then you can induce the connection restricted on this space, let us call Nabla restriction. And this induces the connection on this space, let us call delta minus k. But of course, delta one form and vector field dual to each other. So the connection defined on this space induces the dual connection on this space is not by minus k, something like that. So you get some connection on this space of one form, and obviously this is integrable, not obvious, but this is integrable connection. Then you are going to consider the element such that number of omega equals 0. This is so-called horizontal. Then we say omega is horizontal if and only if there exists a harmonic function on this space such that omega equals d of u and you simplify the system of second order differential equation. But here is a Frobenius algebra structure on the subject bundle, and this is a flat connection on the kind of this structure which is related Frobenius multiple structure. So you get second order differential equation that your horizontal section is given by solution second order differential equation. And I said, so far I calculated some steps there so that it appears to look like very close hypergeometric function, but I couldn't determine the complete. If we know that there's two moments,
Your progress structure, is it related to the, is it interpreted by means of the one-way space stable result stability conditions?
Yeah. Vertical stability condition, I haven't talked anything, but you consider another category where you need to construct some central chart. But then some solution of this equation looks like second order equation. You somehow integration of primitive form. And this becomes the in physics correspond to the central charge. And vertical theory, but the central charge is equal to central charge to get the quality.
Your piece is interpreted as a modularized space of stability conditions.
Is beautiful. Interpretation completed, confirmed, then it becomes peaceful.
So, remembering the integration for which object? Yeah, so you have written down the theoretical integration. So integration over
This one, yes. This is the
this is this formula. The
this is
other one,
defined on S.
U equals to integration of some British vector, right?
Some symbolic here.
Yes.
Yeah, in the practical case, it was really integral of the differential form. But here, I'm talking only symbolic. What's this?
Injection.
This solution space, this space corresponds to this central charge. But I haven't described explicitly that solution. Yes, this is someone I want to work more carefully. Oh, that's the reason why. Yes.
Yes, thanks.
Okay. Let's go.
So,